Hi there, and thank you for your interest in µD3TN. This video is the first part of our µD3TN trilogy, and it aims to provide some general information about our open source lightweight DTN protocol implementation, originally written in the C programming language and now being continued to be developed in Rust. We came up with µD3TN to provide a ready-to-use solution for data transfer in delay and disruption-tolerant networks. Challenge networks as in Car-to-X communication, offshore communication, maritime research, satellite communication, and reliable one-way communication usually do not offer a stable end-to-end connection between the peers. This, however, is required by the protocols of the TCP/IP stack as used in the Internet. That is why, instead, we need the delay and disruption-tolerant networking architecture. Since the network nodes in DTN do not assume continuous end-to-end connectivity, they rather use mechanisms such as store and forward, custody transfer, and late binding in order to exchange data despite waiting periods of seconds, minutes, or even days. The main component of the DTN architecture is the bundle protocol, which makes use of the DTN principles by introducing a dedicated bundle layer. This layer operates on top of different underlying protocols, which are organized in layers as well and provide their service to the bundle layer via a shim layer called convergence layer. In this context, shim refers to the functionality to adapt one interface to another. In our case, it's the interface provided to the bundle protocol implementation, adapting to the one provided to the lower layer protocol. Coming back to the topic, the convergence layer adapter, or CLA for short, is an element of the DTN protocol stack, which enables the bundle protocol to connect heterogeneous networks. This principle is also being explained in the article about ring road networks that we wrote for the IEEE Communications magazine. If you're interested in getting a better understanding of the DTN architecture in general, feel free to check out this link below. Now that we have talked about the core idea behind DTN, what exactly is µD3TN supposed to be? Although it is written µD3TN, we pronounce it like µD3TN. It is an open source implementation of the DTL bundle protocol version 6, which was specified quite some time ago in the experimental RFC 5050, and in fact it was also the world's first implementation of the bundle protocol version 7, which has been specified in the Internet Engineering Task Force RFC 9171. µD3TN can also be used on microcontrollers in addition to POSIX-based systems due to its lean and hardware-near programming. The source code of our µD3TN implementation is BSD and Apache licensed and thus free. You can obtain and review the code and its revision history on GitLab, hence it offers great transparency and can be easily audited. Beside the DTN bundle protocol implementation, µD3TN also provides an interface that allows sending and receiving messages to and from DTN nodes through a simple application agent protocol, or AAP for short, which makes it as easy and effortless as possible for users to participate in DTNs. The AAP allows applications to register a custom endpoint identifier EID with µD3TN to send and receive bundles via this endpoint identifier. The communication via AAP takes place over a plain TCP or POSIX IPC socket connection. That way, µD3TN provides a simple, language-independent way to interact with DTN nodes. However, the main purpose for having the AAP is to spare the applications from having to deal with all the details of the bundle protocol. The applications simply have to hand over their bundle payloads to µD3TN, which then constructs the bundles, forwards them, and also manages bundle fragmentation, fragment assembly, and so on. Also, with respect to the supported underlying networks, µD3TN has a modular design. This makes it possible for µD3TN to be operated on top of many different lower layer network protocols by offering several CLAs and therefore provides great adaptability. The CLAs are running independently and concurrently in different operating system threads. By that, reception and transmission of bundles over multiple, totally different networks can occur at the same time. All in all, the modular design of µD3TN offers maximal flexibility. Since we have the option to add as many new convergence layer adapters to the system as we want, it's no problem to integrate µD3TN with a communication protocol that is not supported yet. This reduces effort as the codebase of various projects can be reused instead of having to develop a full network stack for a specific challenge network. Additionally, the routing has been made independent from the underlying link, which makes it possible to forward between different CLAs. If you are interested in more technical details, do not hesitate to contact us for all kinds of questions. We will give our best to answer them all to you. Furthermore, feel free to contact us for support to integrate µD3TN into your own networking project. As we maintain the µD3TN implementation since 2014, we possess deep technical know-how in supporting and adapting it, which we provide to our customers. We offer maintenance contracts to guarantee smooth operation and rapid reaction times if changes are necessary. In the following 2 videos, we will present to you 2 scenarios which use µD3TN. Definitely check them out for a deeper practice-oriented understanding. Thank you for watching the video and see you next time.